Hey, welcome back, and this is called an array tree preorder traversal. It's question 589, and it's an easy tree question. So what we want to do for this question is we're given a tree, and we want to traverse it in preorder traversal, and our output is going to be just the values of our nodes in preorder. And so essentially what that looks like is, for this tree, we go the current node, and then left, and then right. So that's preorder traversal. So what that looks like is we go with the first node, and we visit the one to its left, and then we'll go left again. We visit that node, and then we have to backtrack back to 5. There is no right node, so we backtrack, and then we go right because we already did current left and now right. So 6, and we backtrack, and we go to the left here, and so forth. So yeah, so if that doesn't make quite much sense, I think once you look at the code, it'll make a little more sense. So let's go ahead, and what we're going to do is we'll instantiate a linked list, and it'll be a linked list of these nodes here with this class defined above. I'll definitely take a moment, pause the video, and look at this class and make sure you understand it. So it's of type node, and we'll just call this stack. It's going to be a new linked list. And so the reason why we're calling this stack is it's going to be treated like a stack, and so essentially you can implement a stack using a linked list by making use of the poll last method. And so that's just like popping off the top of the stack, where you're just grabbing the last element in your linked list. So, and next what we want to use is an array list, because we want to return that list of integers, and they define it here. So we'll make use of that, and we'll just call this output. Okay, so first thing that we want to do with a lot of these problems is we're just going to check if our root is null. And so if so, all we're going to do is return our array list. Just like most questions, there's always this base case of if this is null, return something, and in this case it just happens to be just an empty array list. And so next, just for tree traversal, what we're going to do is, let's think here, have a while loop, and just keep iterating while our stack is not empty. So we can do stack dot, I believe, is empty. Yep. And so we just add a not here while it's not empty. And next, what do we want to check? Just think here. We want to grab the current node. So just prior to this, what we're going to do is we're going to push to our stack our root node. And so if we take our stack and we just add that root node that we're passed at the very beginning, and we're adding this because we know after this point it's not null. So we want to grab that from our stack, and we'll use that poll last method like I mentioned before to get the end of our linked list. So that'll be our current node. Let's just think here. And so then what we want to do is just add the value of that node to our output. So we do output dot add. We just grab that node, and as you can see here, there's a public value associated with it. So we just add that there. And so now that we have the value, we have the latest node, we want to then iterate on all of its children. And so we can use something called collections dot, let's see here, it's dot reverse, or yes, reverse. And so what we're going to do is we're going to take this node and pass its children. And so this is then going into here this list of children, which are of type node, and it's just reversing the order of its children. And the reason we want to do that is we want the top of our stack to be the leftmost nodes. And so by putting in the ones on the right first rather than the ones on the left first, we can ensure that the leftmost nodes are on the top of the stack. And so that's why we want to reverse them. So if we didn't reverse it, we would actually be doing right then left, but we want to give priority to left. So next we want to just iterate through our children. So let's see here. For node I, or for each child of type node, I'm going to iterate through node.children. And then we just want to add them to our stack. Okay, and so after this while loop, we just want to return our output. And so we'll just take another glance at this. Well, first we'll just run it and just see if there's any errors. Accepted and submit it. And success. So why don't we take another look at this? So essentially what we're doing here is, I would say this is the most important logic. This is what allows us to reverse the order of its children. So we're making sure that the leftmost children are on the top of the stack. And so after that, we're just simply adding all of the children and then kind of not recursing, but iterating back on the while loop, and then looking at whichever child is at the top of the stack, adding that value, and then once again adding all of its children, and then getting the leftmost child. And so because we're also adding it all to a stack, afterwards, whenever we pop off the child, we can then look at the node to the right. All right, so I hope that explanation helped things, and good luck with the rest of your algorithms. Thank you.